All right, well, here we're going to go over the answers for 8.3 trigonometry. We're going to be looking at finding sides of right triangles. All right, step one, we want to make sure that our calculator is set to degrees mode. So we're going to look for a little D or deg on the top of our screen. That's really important before we get started, otherwise all of our answers are going to be wrong. Okay, and what we're going to do is we're going to try and follow these 4 steps for each question. If we don't have a diagram, we're going to draw one ourselves that represents a problem. We're going to make sure that diagram somehow contains a right angle triangle. We're going to label each side as the opposite, adjacent, and hypotenuse. Then we're going to choose between our sine equation, our cosine equation, and our tan equation, and we're going to write that out. And lastly, we'll solve for whatever our unknown variable is. Okay, so looking at question 1a. All right, we have an angle here of 40 degrees. We're going to have to start with, well, looks like we already have a diagram, so we don't need to draw one, but we will move on to part 2. We're going to label each side. The long side here is the hypotenuse. It is on the opposite side of the triangle from the right angle. I'm going to label this one hypotenuse. And adjacent, well, adjacent means next to. So I'm looking for a side that's next to 40 degrees. The hypotenuse already has a name, so that must mean this other side here is next to and adjacent to 40 degrees. I'm just going to abbreviate that ADJ. And that leaves only the opposite. Now, the opposite side of 40 degrees is all the way over here, and that is our variable x, our unknown. I'm going to label that OPP. All right, so that's step 2 done. Now we're going to move on. We're going to see if we can figure out which of these 3 equations is going to be useful for us to solve for x. Well, first of all, I would say x is my opposite. So I need to choose an equation that contains the opposite side in it, which means out of sine, cosine, tan, cosine is definitely out. So sine has an opposite over hypotenuse. Tan has an opposite over an adjacent. All right, so if I look, I see that I have information about my hypotenuse, but I don't have any information about my adjacent. So tan is actually also out, and we're going to want to use our sine ratio for this question. So the next thing I'm going to do is write out that equation for this ratio. So it's sine, and this little symbol here means angle. So I'm going to write in the size of my angle here, which is 40 degrees. And then I'm going to write the opposite. So I can write OPP, I can write opposite, or I can just write x. Really, just any symbol that represents that we don't know what it is. And the hypotenuse is 12 millimeters. I'm just going to write that as 12. Okay, this is a pretty straightforward algebra question. At this point, we're moving on to part 4. We need to solve for our unknown variable. And we say, okay, well, what's happening to my variable? Well, it's being divided by 12. I got to do the opposite to both sides of the equation. Those are my algebra rules. So to do the opposite of dividing by 12, I'm going to multiply by 12. But I got to do that to both sides of the equation. Now, dividing by 12, multiplying by 12 are opposites, so they cancel out. And good algebra habits mean I'm going to rewrite that equation now. So I'm going to write 12 times sine 40 degrees. And that equals x. Okay, so that means I'll get my calculator out of this stage. And I'll just type in 12 times sine of 40 degrees equals, and equals 7.71345 millimeters. Now notice the question says round to the nearest tenth. All right, so that means we're going to round to 1 decimal place. So it tells me 7.7 millimeters is my length of side x. Okay, so hopefully the next ones are going to go a little quicker now that we understand that process. Okay, let's look at question B. Same thing as before, we already have a diagram, so we'll move on and we'll label up our sides. Again, we're going to label the long side, the one opposite the right angle, as the hypotenuse. This one all the way on the other side, that's the opposite. And this side here is next to 9 degrees, so that's the adjacent, because adjacent means next to. All right. Well, I'm looking for my x, my adjacent. So I need to make sure an equation contains adjacent. That means sine is out. Okay. And between these two, the cosine and the tan, I'm going to want to make sure that I'm also using some information I have in this triangle. So I also know the hypotenuse. So that means I can use cosine because I'm only going to have one unknown if I use this equation. If I use tan, I'm going to end up having an unknown opposite and an unknown adjacent, and that's not going to be solvable. So we'll use cosine. Okay. So I'm going to write out that equation. Cosine 9 degrees is equal to my adjacent x over my hypotenuse, 60 meters. All right. It looks like the exact same algebra question that we had before. Really, we just have x is being divided by something. This time it's 60. So I'm going to do the opposite. Multiply both sides by 60. That undoes 60. They cancel out, and I get x is 60 times cosine 9. I didn't leave myself tons of room there. Okay, so let's find out how big that is. 60 times cosine 9. So we find that's 59.261, rounded to the nearest tenth. That's going to give 59.3. What are my units? Meters. That's the length of x. Now I can always just take a second to check. Does that make sense? Well, it looks like it's around the same length as 60. It's in the same neighborhood. But I was expecting it to be smaller because the hypotenuse is always the longest side, so that's in the realm of possibility. I think it's worthwhile taking a second always to just check and make sure answers make sense before we move on. Okay, moving on. So what do we got here? We're going to start, again, we've given a diagram. We'll label each of the sides. This will be the hypotenuse here, opposite all the way on the other end of this triangle, and adjacent is the side right next to our angle. The one that isn't our hypotenuse, that's the adjacent here. And what are we doing here? Now it looks like we're comparing an opposite and an adjacent. Okay, so we talked about memory device, SOHCAHTOA, to help us remember SOHCAHTOA. Our ratios, if we don't have them in front of us. Now, on our provincial exam, we're always going to have our formula sheet in front of us that will be giving us these three. They don't need to be memorized, but having something in our memory that we can refer to can make the process a little quicker. Okay, we need to compare, looks like we're comparing an opposite and an adjacent side. Okay, so that means it looks like we're going to use tan, opposite over adjacent, TOA. Okay, I'm going to write out that equation. So that means tan, again, tan of my angle, the angle's 48 degrees, is equal to the length of my opposite side, which looks like it's side x, over my adjacent side, which is 100 feet. Okay, again, you're going to see a pattern here, same algebra question style. We got to multiply by 100, because right now what this says is that whatever tan 48 is, that's like 1/100th of x. But I don't want to know what 1/100th of x is. I want to know what x is. So in order to find out what x is, it means I got to multiply both sides by 100. Okay, and x is being divided by 100 and multiplied by 100. Those are opposite operations. They cancel out. And I get x is 100 tan 48 degrees. Okay. So, what do I got here? 100 times tan 48 gives me a value of 111.061, but again, we're asked to round to the nearest tenth. So looking back at this calculator, it says 111, and we're going to round that decimal up 1, because that's closer to 111.1 than it is to 111.0. Okay, so it's 111.1. What are my units? My units are feet. Equals x. Okay. And if I look back at my diagram, yeah, I buy it. This guy is going to be a little bit bigger, it looks like. Now, this diagram isn't always to scale, but I can make that reasoning by saying that if this was 45 degrees, I would expect this to be an isosceles triangle, because this would also be 45. Since this is a little bigger, I would expect that side to be a little bigger than this one. Okay. Moving on to D. Okay. As before, we're going to start by labeling up our triangle, opposite, adjacent, hypotenuse. So I'll start with the opposite this time. This guy is always on the opposite side all the way over here. Adjacent, well, this guy is next to my angle. It's adjacent to it. And the hypotenuse is always the longest side. Okay. Well, it looks like here we're comparing the adjacent and the hypotenuse. So if I think of my memory device, SOHCAHTOA over here, it looks like cosine is the ratio that compares adjacents and hypotenuses. Okay, great. So that means I'm going to write my cosine equation out. Cosine of 31 degrees is equal to the ratio of my adjacent, which is 21 centimeters, over my hypotenuse of x. Okay, here we have a new algebra situation. Now, it looks pretty similar to how we began our last algebra equation. The difference is that x is now in the denominator. X is in the denominator. That's a big idea. It means our regular algebra dogma isn't going to work. We need to address this problem before we move on. Okay. Well, thankfully, I know a trick for getting rid of fractions in equations. There's this trick that if we multiply both sides of the equation by the denominator, so if we multiply both sides by the denominator, denominator means the bottom of a fraction, that is going to make our lives easier. It's going to get rid of fractions in general, and specifically fractions where x is in the bottom of them. All right, so we're going to multiply both sides by this denominator. We're going to multiply both sides by x. Now, I feel like I've written maybe a few things here, and it might be a little confusing, so I'm just going to rewrite this over here. Cosine of 31 degrees is equal to 21 over x. All right. Now, it's tempting to say we divide by 21, by the way. And I would understand why you would think that, but that would undo multiplying x by 21. This is not that situation. It's a little bit different. All right. So as I said before, we're going to multiply both sides by x. So I'm going to multiply this side by x. I'm going to multiply this side by x. All right. So what happens here? Okay, I've got x times cosine of 31 degrees on the left-hand side, so I'll just rewrite that. X times cosine 31. And on the right-hand side here, well, what do I have here? I've got, this says 21 is being divided by x, and it's being multiplied by x. So when I have a number and I divide it by something and then multiply it by that same number, well, those are also opposite operations. Just as before, we had x being divided by 100 and multiplied by 100. We decided those were opposites and they canceled. It's the same thing if we don't know what that number is. We're still dividing by that number x and timesing by x. So those are opposites as well. So those cancel. Okay, that leaves us with just 21 over on the right-hand side. All right, we're almost there. X is not isolated, but it's not in the denominator, which means we can move on. We can use our regular algebra rules, and we can say, okay, x is being multiplied by cosine 31 degrees. Well, if I want to get x by itself, I must do the opposite of that. What's the opposite of multiplying by cosine 31? Well, the opposite is dividing by cosine 31. So I'm going to divide cosine 31 on both sides of the equation. And by multiplying and then dividing, The reason I divided in the first place was so I could get rid of this. They cancel out. They're opposites. And it leaves us with just an x on the left. And on the right, I have 21 over cosine 31. Okay, I don't know what that is, so that's why I have a calculator. So 21 divided by cosine 31, what does that give me? It's going to be 24.4993 and so on. X is equal to, and that rounds to 24 point, I'm going to draw a little line there, but I got to round this guy up to a 5 because this number is bigger than 5. 24.5, and my units are centimeters. 24.5 centimeters. Okay, so as we can see, question D involved some more sophisticated algebra, and we're going to see that the next few do as well. All right. So, okay, I guess we've got a diagram, so we're good on step 1. Step 2, we're going to label this up. I think you guys are probably getting pretty good at this, so I'm just going to do this kind of quickly. So I'm going to call that just A, H, and O. Opposite, adjacent next to, hypotenuse is long one. Great. What are we comparing? Well, it looks like we're comparing the opposite and the adjacent sides. Okay. Well, which trig ratio, SOHCAHTOA, which one compares opposites and adjacents? So if I look, opposite hypotenuse, adjacent hypotenuse. Okay. Tan compares opposites and adjacents. Okay, great. So I'm going to use a tan formula. Tan, 75 degrees. That's my angle always. And that's equal to my opposite, 250 kilometers. Oops, that's not 250. I'm going to try to fudge that a little bit. There we go. 250, nobody noticed. Over my adjacent, which is x, my unknown. And you may notice that we are in the same situation we were in before. X is in the denominator again. So we got to multiply both sides by that denominator to get started. So the first thing I'm going to do is I'm going to multiply by x on both sides of the equation. Okay. Now these x's cancel out, just like they did before, and we end up with 250, and this is equal to x times tan 75. Great. Now, opposite of multiplying by tan 75 is dividing by tan 75, so I'm going to divide both sides of the equation by tan 75. They cancel, and we end up with just an x, and that's equal to some number. We're going to find out what it is. So it's 250 divided by tan 75. Okay, 250 divided by. Great, okay. And I get 66 point, oh, okay, we got some interesting rounding here. I'm going to write the whole number out. Okay, 66.987 ... Okay, so we got to cut this guy off right here. All right, so that means we got to say, is this bigger than 5 or equal to it? The 8 is bigger than 5, so this guy rounds up, but he rounds all the way up to a 0, or rather a 10. You can think of it as being a 10. We're going to carry that 1 over here. So that actually means that when we finish rounding, this extra 1 from that 10 gets rounded up to the 1's place, and that should become 67.0 kilometers. All right. So on to question F, 1F. All right, same thing as before. We're going to label the opposite, adjacent, and hypotenuse. Okay, so we'll start with the adjacent this time. Adjacent, opposite, and hypotenuse. If that went quick, I'm going to ask you to refer back to some of the earlier questions where I labeled those up a little bit more slowly. And then we're going to say, okay, what are we comparing? Here looks like we're comparing an opposite and a hypotenuse. So which of our trig ratios compares opposites and hypotenuses? Well, it looks like sine does. SOHCAHTOA. So, S-O-H. All right, so that means we're going to write down the sine ratio, and the sine ratio is sine of 80 degrees and that's equal to our opposite, 67 inches, divided by our hypotenuse, which is unknown. I'm just going to write it as x. Okay, we've seen the situation before as well. While it might have been hard on the first one, you're probably getting a rhythm for it by now, so we're just going to multiply both sides by x. They cross out, and we get 67, and that's x times sine 80 here. Great. Okay, we're almost done. We got to divide by sine 80. You're probably noticing by now that these questions involve fairly repetitive operations, and that's true. X is equal to some number, 67 divided by sine 80. All right, so 67 divided by sine 80, 68.03. That's some nice easy rounding here. We'll call it 68.0 inches. Okay, last question, question 2. All right, so this question is not a question that gives us a diagram, meaning we're going to have to create our own. I'm going to start with a highlighter, and I'm going to attack and highlight any key words here that are key terms that I think are important. All right, so let's read this through. Mr. Tang needs to place a 5-meter ladder against a tree to safe a cat. Well, I think you can imagine I probably meant to say save a cat. So the first thing I'm going to do is I'm going to cross it out. I'm going to write save. All right. Going back to that sentence, what do we need? Okay, looks like it's important that we're talking about a 5-meter ladder. And it's going to be against a tree. Okay, I'm going to highlight that too. Okay, because I can imagine a tree, and I probably imagine a tree is vertical, which means it's going to be straight up and down. We'll come back to that. All right, so what do we know? He knows that the safest angle for a ladder is 75 degrees between the ladder and the ground. So I guess what that means is that when a ladder has been placed so that the angle between the ladder and the ground is 75, that somehow the safest angle that makes it a ladder the most stable. All right, so I'm going to highlight that, 75 degrees between the ladder and the ground. The question is, how high up the tree should Mr. Tang place his ladder? All right, so I'm going to use I like to use a different color to highlight the question itself, so I remind myself what I actually am trying to solve for. So the question is, how high up the tree should Mr. Tang place the ladder? Okay. All right, so we're going to have to create a diagram out of this. And this is not always the easiest task. It takes a bit of practice. So we're just going to try and get our hands dirty here and see what we come up with. All right, so we know that we got a tree. Okay, so I'm going to start by drawing a tree. So I'm going to draw it. I'm not going to draw too much detail because I might get confused, but I'm going to draw a little clump at the top to make me think that it is a tree. Now that is a work of art. All right. And it's some height, but I don't know how high it is, so I'm also going to indicate that I've got the ground here. Okay, great. And we can imagine the tree, like most trees, are somehow vertical relative to a relatively flat ground. Obviously, if this is on a slant or if the tree is slanted, that's a different problem. It doesn't mention that, so we can assume that these are simple dimensions here. All right, now what do we have? We got a 5-meter ladder that's going to be placed against it. Okay, so I guess that means that I've got a ladder placed against it like this. And that ladder's going to meet the ground. And what does it say? Safest angle is 75 degrees between the ladder and the ground. Okay, so this is my ladder. Oh, I should probably label the length. That's 5 meters. And that's from here to here. Okay. And 75 degrees is between that ladder and the ground. So this is 75 degrees. And the question is, how high up the tree should Mr. Tang place the ladder? Okay, so that really is asking the question, how high up the tree? So like, where should he place that end of the ladder here? Okay, so we'll make that our variable x. Well, that's a very nice diagram, but I'm starting to get confused by all the extra stuff here. So what I'm going to do is I'm going to take that information, I'm going to rewrite it as a triangle. Just a simple triangle. However, before I do that, I'm going to recognize that I assume that the tree is vertical and the ground is horizontal, which means they're going to meet at 90 degrees, so I'm going to add a right angle in there. And there's my right angle triangle, so I'm going to simplify this situation by just drawing the right angle triangle. Helps me focus on what I'm doing. That's 5 meters, and that's 75 degrees. Okay. Great. Well, the first step was to draw a diagram, and that looks pretty good. Then we're going to move on now. We're going to start labeling this thing. Okay, so that means this must be the adjacent side. Okay. This must be the side opposite, on the opposite end of the triangle from the angle, so that's the opposite. And this must be the hypotenuse, this long side here. Great. Looks like we're comparing opposites and hypotenuses. All right. So if we go back to SOHCAHTOA, we need a ratio that compares an opposite, an O, and a hypotenuse, an H. And it looks like we're going to use our sine ratio again. Okay. So our sine ratio says sine of my angle, 75 degrees. That must be equal to my opposite x over my hypotenuse 5. Great. Nice and easy algebra to solve. X is being divided by 5. I want to get x by itself, so I'm going to undo, or do the opposite of divided by 5, which is multiplying by 5. So I'm going to multiply both sides by 5. These are opposite operations. They cancel out. I get x is whatever 5 times sine 75 degrees is. Okay. 75. All right. So what do I see? I see that I need to place, or Mr. Tang rather, needs to place his ladder 5.8296 meters up the tree. We look at the question. Does it ask for any particular rounding? It doesn't, so really any sort of rounding would be acceptable. However, if I rounded to the nearest whole number, that might be a little misleading. It wouldn't be very useful because it would imply that he'd need to place it 5 meters up the tree. And the only way to do that is if the ladder's laid right up next to the tree. So rounding to the nearest whole number might be a little too much rounding. So maybe round to the nearest 1 or maybe 2 decimals. I'm going to round to 2. So that way Mr. Tang has a little bit of extra information if he needs it. He can always discard it later. So I'm going to say Mr. Tang should place the ladder 4.8, and that rounds up to a 3 meters up the tree. Now, with a word problem, it's good standards and practices to write our answer as a sentence. All right, so Mr. Tang should place his ladder 4.83 meters up the tree. And I might actually put a big box around that to indicate that's our answer. And there we go. That is how we find the length of sides with basic trigonometry.